Hey Comets, it is Doc here, and yes, you're going to notice I'm going to have amazing change of clothes instantaneous later on because when I started the geometry review today, I completely forgot to record the first 15 minutes. So I'm going to reteach that part first, and then it'll go from there. So yes, I'm wearing black shirt now, and then magically, mid-video, I'm going to end up turning into wearing a flower shirt. Who knew? So today we're doing the interim review for geometry. I've intentionally picked all of the questions to be DOK level 1 so that they're not going to be in depth, that we have a lot of reading to do. It's more just to refresh your memory about the content. In total, this video should be less than an hour long. I cover about 40 different questions. This is very heavy in transformations, but still it's good remembering of what we need to do. Let's go ahead and get started. We did not play Kahoot today for geometry. We didn't play Kahoot for anything because the videos just ran so long. So here what we have is, let's follow this transformation. Where's my mouse? Hello, mouse. Right here, I've got these two triangles can be shown to be congruent by which transformation. So, my light is making me have a shadow. That's making me look really bright. Okay, so basically the reflection over the x-axis. Well, let's see. We see that basically it just flipped, and it flipped over this line. If it was a reflection over the x-axis, that means it would flip down, and it would be like this. And it's not like that, so it's not going to be choice 1. Reflection over the y-axis, that actually is what happened. It flipped from here to here over the y-axis. We know it's the y-axis because it's labeled by the letter y. So that is the correct answer. A translation of 4 units right would end up just having everything move this way. So it would look like this, which is not what's happening. And a rotation of 180 degrees would have the points be down here, which again is not what's happening. So that's why you're left with choice letter B. Describe the transformation that maps ABCD onto PQRS. Just as a reminder, we've talked about this before. We really don't need to do this for this problem, but anytime they give you letters like that and they say that it maps onto something else, please take the time to just write it out. That way you can easily see that A would map to P, B maps to Q, C maps to R, and D maps to S. That's definitely going to be a question. Okay, so now we need to look at how does this end up mapping out for everything else. So I don't know why I have all this stuff still on here. Let's get it off. Okay, so first of all, we know that because C is pointing up and R is pointing down, we know it's a rotation. So right away, I'm going to eliminate choice C because choice C does not mention rotation. So now I know it's between A, B, and D. Now, one little point, this says rotate. It doesn't tell you how many degrees. For this purpose, we're going to assume it means 180 degrees and it was a typo. So let's see. First, it says translate 4 units right. So that means the new shape would be like this. And then it says rotate 180 degrees about 5,1. Well, that's good. It is going to be rotated about 0.51. So because of that, we can eliminate choice D. But here's what happens. When it's rotated by 5,1, see how there's this 3 units long here? With the rotation, it has to be 3 units down here. This is what the rotated figure has to look like if we rotated it around 5,1 and we had moved it 4 points to that spot. So it's not going to be letter A. So then let's double check and see what, by process of elimination, we know it's going to be letter B, but let's just double check. So it says reflect again, well, x equals 2. Well, here's x equals 2, this line. So when we make our reflection, that leaves that the graph would look like this. And see how the figure has the short side here and the short side is here? That's the correct rotation. So our answer is going to be choice B. Now, technically speaking, I would say B is not correct because B doesn't say 180 degrees, but we'll just assume it's 180 based on human error. All right, next it says, which transformation will map the figure onto itself? Remember, we can do that by lines of symmetry or we can do that by rotations. Let's talk lines of symmetry first. Where can we fold this perfectly in half? We can fold it in half at y equals +1. And we can fold it perfectly in half going down at x equals -1. I'm sorry, x equals -2. Because we have those two lines of symmetry that intersect in the middle, we also know that we've got rotational symmetry around the point -2, +1. So that's what we know is fact. So anything that's not one of those things, we can eliminate. So can we reflect it on y equals 2? Nope. That wouldn't put it on top of itself. We have to reflect on y equals 1. Can it reflect across y equals x? Nope. Y equals x would end up putting the figure down here. So nope, can't do that. Can we reflect on x equals -2? We can. That's what we decided right here. So that's our correct answer. And then, of course, 180 degrees about a point would put it down here. So it's not going to be choice C. Letter D, same idea. It tells us it's centered at 0, 0, and it tells us the vertex is at 0, 4. And it's a pentagon. So what can we do? Well, it says, can you reflect on line M? We could, but if we reflect on line M, this is 3 units up, because line M is at y equals 1. So that means that our new vertice would have to be 3 units down, which puts it right here. And there's no vertice there. So it can't be choice A. For it to be choice B, we know that this vertice is 4 units up because it says it's at 0, 4 is one of the vertices. So that means our other vertice would have to be down here at 0, -4, which it's not. So can't be choice, can't be choice B, because then that would be the x-axis reflection. So now we're at 100 degrees versus 144 degrees. Well, I taught you that anytime you have something that says regular, which this should but doesn't, it's pentagon, we can assume all the sides are the same, then we're going to do the 360 degrees. So we're going to do 360 divided by the number of sides, and that gives us 72 degrees, which is still not one of the answers. And then I taught you do 72 times 1, 72. 72 times 2 is 144. And so that is the correct answer. So again, if you can't find a perfect line of symmetry, then what you're going to need to do is just go ahead and do the rotational. Now, technically speaking, if they mention the y-axis instead, that would be correct. The y-axis is a line of symmetry. If they mentioned x equals 0, that would also be correct. But those were not any of the answer choices, so we had to go with choice D. All right, next, the sequence of transformations that maps ABC to RST. Ooh, guess what? We got letters. What do that mean? A, B, C, R, S, T. That way we can just always pay attention. Here it's kind of obvious, but still get in the habit of doing that. Reflect triangle ABC on x equals -1. So if we do that, this is 1, 2, 1, 2. So that would put our shape here. Okay, and then it says 1 unit down. We already know that's not going to work, but let's just prove it. Here's 1 unit down. Doesn't work. Nope. Goodbye. Okay, next it says to instead do same thing, -1. This time it says 5 units down. 1, 2, 3, 4, 5. There you go. It maps. It's going to be choice B. The other ones, it says rotations simply because we know it's a rotation of 90 degrees. If it was a rotation of 90 degrees clockwise, it would go like that. If it was a rotation of 90 degrees counterclockwise, it would look like that. And it doesn't look like either of those, so we could have eliminated C and D from the beginning simply because it's not a rotation. All right, next, what is the image of point C after rotation of 180 degrees? Point C is at 7, 4. Now, hopefully you remember that I taught you when we do rotations, we use our hands. That way we don't have to memorize the formulas. So we've got 7 here and 4 here. Every time we rotate 90 degrees, we flip-flop. So we've got 7, 4, now 90 degrees, 4, 7, back to 180, 7, 4. So we know that our new point has to have the numbers 7 and 4. Next, we know in order to get to 180, we do 2 quadrant jumps. Every quadrant jump is 90 degrees. Here's quadrant jump 1. Here's quadrant jump 2. We could have also gone the other way. Puts you in our same point. That means our value is going to be somewhere in this quadrant, which is quadrant 3. And of course, everything in quadrant 3 is negative. So our answer is -7, -4, or choice A. Boom. Next one. Which of the following is equivalent to a rotation of 180 degrees? This one, friends, you just have to know it. It's choice D. It's not going to be y equals x because technically speaking, for y equals x, all you're going to do, if we start with xy and you're left with y equals x, that's going to take you to yx. And then when we do a reflection on negative x, that's just really a reflection on going the other way and changing the signs back, and that's not it. So it's not A. It's not B because it's their rotation, so it can't be B and C. So all it is basically is we're not switching anything like that. It's just change the x, change the y, and you're done. Which transformation maps ABC to A prime, B prime, C prime? Well, let's see. There's no rotation. If I go like this and connect these dots, I can see that all of them are up to over 3. So I know it's got to be a translation. And as I just shared with you, how did I do it? Well, for the x, I went over 3 plus 3. And for the y, I increased 2. So the only one that could be is choice A. Next. Let's see, based on this, which is true. So A to A prime is parallel to B to B prime. Yep, that's true. And they're not congruent. Well, that's false. So it can't be choice A. A in A prime and B prime are congruent. That's true. But they're not parallel. False. So it can't be B. C is they're parallel and congruent. That is true. D says they're neither. That is false. So that's it. So in the next seconds, I'm going to perfectly, wonderfully change shirts. Bye. So let's go ahead and move on to this next one. This next section deals with our favorite math song in the universe. Side, angle, side. Side, side, side. Angle, side, angle. Angle, angle, side. And then a hypotenuse leg. There's a bunch of questions on this on your EOC or on your interim. So we know that it's side, angle, side, 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 angle, side, angle, 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 side. And then we also know hypotenuse leg. So let's pay attention to what we got here. Here we see that these lines are congruent. We know that they're congruent simply because of these markings, congruent. Also, we see that the two triangles share the side, so we know that they're congruent because of the reflexive property. So which postulate proves that these are congruent? This is our side, side, side. Choice D. Now, one other image to be mindful of is images like this. That gives us vertical angles, so that means we might have angle, side, angle, or side, angle, side. What transformation maps RF onto FQ and AR onto AQ? Let's delete all my markings here and do this one again. Okay, well, it wants us to do, okay, RF, this one, goes to FQ, AR goes to here. How did I do? Did it translate? Nope, it flipped, so it can't be this one. Did it rotate? If it rotated, it's going to be choice B. It was a reflection. If it rotated, the difference would be that here would be our long point here, and then here we'd have our long point like this. That would be a rotation. So that's why it's not C. And 90-degree rotation would look like this. So that's why it's not D. If segment RQ is drawn, which of the following is true? So let's see. Segment RQ. Let's delete all this stuff and see what we got. Mouse eraser. Okay, segment RQ is this line. Pretending that it's straight. Is AF perpendicular to RQ? Yes, it is, because this is actually a kite. It's a kite because consecutive sides are the same. So because consecutive sides are the same, we know it's a kite, which means that this is perpendicular. So this is true. AF bisects RQ. That is true because the other thing of a kite is that it bisects the shorter line. And the last one says that AF or RQ bisects AF. I hope you can tell by looking at it that this right here is not as long as this, so this is false. So our answer is choice B, 1 and 2 only. Oh man, we still got more transformations. Okay. Next transformation talks about which of the following is not an isometry. So anything that's not an isometry, just got to have the word dilation in it. If it's got a dilation, you already know it's not an isometry. So translation, that's fine. Rotation, fine. So that's correct. Then reflection, that's correct. Rotation, translation, that's correct. So the one that's actually incorrect happens to be the dilation. That's the one, choice B. That one was super easy. Next, let's take a look at this one, make it smaller. Okay, this next one is yet another one. I don't know why they have so many questions with rotations. Okay, which of the following is a rotation of ABC 90 degrees counterclockwise? So counterclockwise means that when we do our rotation, we're going to be moving the opposite direction of a clock. So this point right here is 0, 1 or 1, 0. So when we flip it, we get 0, 1. So this point will be right here. B is at the point 3, 1. So when we flip it, we know it's going to be 1, 3, and we know it's going to be in this quadrant. So over -1 up 3. That's going to be our B. C is 3, 4. So when we have 3, 4, we flip it, 4, 3. So we're going to go 4, 3, and here is our C. So choice A. That was good. I'm really tired of transformation, so we need to get off of these. Next. You know me, I tell you the truth. Okay, this is more with, I believe it's AKS 10, looking at, I could be wrong, but looking at side, angle, things like that. Okay. Next. What additional information do we need to prove this? Now, this is one of the reasons why I wanted to use the highlighter tool, because one of the questions, if you're one of my students that you saw on Friday, says you have to prove it using side, angle, side, or using angle, side, angle, or something like this. In this case, it doesn't tell you that, so you can pick whichever way that you want to do it. But you would technically need to know how to do it on the test if they give you a specific way. All right, here it says, what other information do we need? Well, right here we've got this angle and this angle are congruent because of vertical angles. So the only possible way that we can get congruency is if angle A is congruent to angle D. We could get that by angle, side, angle. Or we can get it, oh, that's not true. There's 3 ways. Or we need to know this side right here and this side right here, which is BC equals EC. That would give us side, angle, side. This is angle A is congruent to angle D. And we also could do angle, angle, side, which I totally zoned about. In order for it to be angle, angle, side, we would need this angle here and this angle here. And that would give us angle, angle, side. So let's see what our options are. BC equals EC. Well, there you go. That was easy enough. Right there. It's not AB equals DE. That would be angle, side, side, or side, side, angle. AC equals DC. We already have that, so that's not an additional piece of information. And then angle ACB is congruent to angle DCE. We already have because of vertical angles. So that's why it's got to be choice A. Which statement is correct? Let's see. Well, we need to prove how. Angle, side, angle. They're congruent. All the letters match here, so we don't really even have to pay attention to this. So the postulate is angle, side, angle, choice B. Hopefully you guys are thinking like, man, I remember a lot of these. I just forgot when I took Doc's test on Friday. Next. If a rigid motion maps KMQ, what do we do? Okay. Such that which segment is congruent to RW. Got it. So this one is the one that I taught you. Line up the letters. So if we know that we have K, M, Q, and that measures W, or matches, corresponds is the proper word, to WJR, I write them on top of each other. That way it's super easy to figure it out. We're looking for RW. So we're looking for, this is our first one, and this is our second one. So here we have our RQ. Oh, that is so bizarre. All of a sudden, I have captions going. Okay, so RW, that's going to give me Q has to be my first one, and K has to be my second. Q, K, and that's it. Okay. Next, if the figure, in the figure, which is QS, is congruent to QS, why? Why is this itself? We already talked about it earlier. It's itself because of the reflexive property. I've never heard of the symmetric property. All altitudes are congruent is not correct. All right angles are congruent. And the transitive property for congruence you would only use if you were doing proofs and you had this equals this, and then the first thing equals the third thing. So that's why it's not going to be the last one. 18 I stopped at. Let's get our next pick. We are about halfway through. Okay, in this picture, the figure represents wooden truss used to support the roof of a garage. Which postulate can be used to prove these are congruent? Well, they gave us a right angle for a reason, but that doesn't necessarily guarantee its hypotenuse leg. Here's our right angle. So because this is our right angle, we know this is our hypotenuse, and this is our leg. So because of the reflexive property, it is going to be hypotenuse leg. It wouldn't be hypotenuse leg if they gave you, for example, the bottom two measures. Then it was a trick question and it's side angle side. Okay, if these are congruent, which is congruent to angle U? Again, anytime they give you a congruency, please write one on top of the other. Make your life easy. Then when they say what's congruent to angle U, you're just like, duh, angle R. Done. Okay. Which of these does not preserve distance and angle measure? If you get anything like that wrong on the test, I'm going to cry. It's dilations. Everything else preserves distance and angle measure. Dilations do preserve angle measure. They do not preserve distance. Okay. Next. Okay. Why do they have so many transformations? Jeez. For geometry, we might need to do another review or something because I don't think there's going to be this many transformations on your test. And this whole review sheet is pretty much transformations. Let's take a look. All right. If the triangle 1 is transformed as in the diagram, resulting in triangle 3, describe the transformation. So it kind of is just there to help you. So how did it get from 1 to 2? Well, all it did was slide. Anytime we have a slide, it's a translation. So it's not going to be B, it's not going to be C, and it's not going to be D. It's going to be 1. Basically, it was a translation of 1, 2, 3, 4. So technically speaking, it was a translation of 4, 0, followed by a reflection of the x-axis. It should be a lowercase r. That's what that one is. Rigid motion is the same as an isometry and isometric transformation. Which word is not synonymous with rigid? Similar. Identical obviously is the same. Congruent also means the same. And isometric obviously goes with rigid. So similarity is, of course, dilations only. Okay, next one. Describe the transformations. Are they congruent? You will not have one of these on your test because there is no similarity or dilations on your interim. But let's take a look. All right, here I noticed that the I noticed that they keep the same focus, like their orientation. All it did is it moved. It moved 2 over and however many down. 4, 1, 5 down. So my transformation is xy translates to x plus 2, y minus 4. And because it is a translation, that means right away that I know for a fact that it's going to be a isometry. So yes, it's congruent because it's a simple translation. Here, they show me the perpendicular because anytime you do a reflection, you need to reflect on perpendiculars. Here, I notice it goes 3. Here's my 3. I don't like this color. Here, I've got 1, 1. Here, I've got 3, 3. So I know it's a reflection. It's a reflection on the y-axis. So reflection, y-axis. Is it congruent? Yes, it's congruent because it's a reflection. Reflections are isometries. Here we've got dilations. Here it was big. Here it's small. Remember, dilations for our scale factor is new over old. We also need to know the center of dilation. That's why they had all those lines pointing at 0, 0. We do not have to say center of dilation is 0, 0. It's assumed unless it said otherwise. For dilation, we write our big D. Our scale factor is our new one is the largest one, which has this length is 6. Our smaller one, triangle, is our original, which is 3. So we have a scale factor of 2. So you could just write D2. And no, it is not congruent, but it is similar because the angle measures are the same. The shape looks about the same. The only difference is the size. Last, it has this nice little arrow telling you, ha, I turned it. It was a rotation of 90 degrees. Remember, it's counterclockwise. We always assume it's counterclockwise unless it tells us otherwise. If it is clockwise, we would have done negative 90 degrees. So if it went from here to here, we would have said negative 90. And yes, it is congruent because it is a rotation. Okay, next, 26. I know I'm going fast. Hold on one second. Are you okay? I know I'm going fast because I really, really hope this is review. Again, all of these questions I intentionally did as DOK level 1 questions, just so you would not be stressed out with it in depth. I was trying to review content, so that's why we're doing it this way. Here's our next one. In the diagram below, lines N and M are cut by transversals P and Q. And then what would make them parallel? So that's actually a really good question. In order for it to be parallel, what we need to do is we need to make sure that we have corresponding or alternate interior or some type of angles. So here's angle X. So we have to pay attention to what angle X maps to. If this is angle X, I need a pen. Come on, kid. Okay, if this is angle X here, angle X is going to map to this value. So that's what we have to figure out. So we know that this is a straight line, and we know that straight lines have 180 degrees. So because we have these two pieces, all we need to do is do 180, subtract 80 plus 30 is 110, and that's how we get this has to be 70 degrees. If that's 70 degrees, then this can be 70 degrees because corresponding angles are congruent. And then because it's corresponding angles and they're both 70 degrees, then we can say the lines are parallel. In the diagram below, BCD, we have side DB is extended to point A. What other pieces of information must be true? Hold on one second. So let's take a look. Well, the only reason why they would mention an extension is for them to tell you that this angle here equals this angle plus this angle. So basically, they're telling you angle CBA, or now I notice all of those are ABCs, so we'll say it that way. ABC has to equal angle C plus angle D. That's it. And then, which statement must be true? Okay, is it true that we know that that formula is true? That's called the exterior angle theorem. Does C have to be bigger than D? Nope. They have to be equal to whatever the outside angle is, so it's not this one. Does angle ABC, the outside angle, is that smaller than angle D? No, because we have to add angle D with angle C to get ABC, so it's not going to be choice 2. Is ABC larger than C? Yes, it is, because we know C is here, so even if D is 1 degree, it still makes ABC larger. So this is the correct answer. This is that they're greater than, and we know that's not true because they have to be equal. Next. Okay, which of the following is the precise definition of an angle? The precise definition of an angle is you need to make sure you have a common endpoint and you need to have ideally rays. Okay, so let's see. The intersection of two non-parallel lines. Nope. The corner of a geometric figure. Nope. A common endpoint of two diverging rays or line segments. That's pretty precise. I like it. The figure formed by two rays diverging from a common endpoint. Honestly, I don't know what they wanted you to put for this one. Let me see. For number 28, they wanted you to pick D. So the figure formed by two rays diverging from a common endpoint is choice D. Okay, next, when writing a geometric proof, which angle relationship alone can be used to justify congruent angles? So we know we're talking about angles, so we have to make sure whatever we check is angles, and we can write it in one line. The only angle relationship that you can write down in one line is vertical angles. Choice D. That's it. Okay, next. Now we have a bunch of questions that relate to a common picture. So we're nearing done. We'll probably be done in about 15 minutes. Let me pull this up for you. New. Again, if you have questions, please ask. Okay, which of the following proves that they are parallel? Okay, so angle 8 and angle 2 are alternate interior angles, yes, and supplementary. No, they're not supplementary. Alternate exterior angles are congruent. Angle 7 and angle 3 are alternate exterior angles. Nope, they're corresponding angles. Yes, they are congruent, but still it's not choice B. Angle 7 and angle 2 are same side exterior, yes, and they're supplementary, yes. So it's choice C, but let's prove that it's not choice D. Whoops. Choice D says angle 3 and angle 5 are same side exterior. They're not. They are alternate interior, and they're also congruent, not supplementary. Okay, which statement proves lines M and N parallel? I guess we're doing this again. Now we're going to look at 8 and 2. Are these literally the exact same questions? Nope, they're not. Okay. 8 and 2 are alternate exterior angles. Yes, they are, and they're congruent. There you go. 7 and 3 are corresponding. That's why it's not this one. 7 and 1 are same side exterior. They're not. They're alternate exterior and congruent. 3 and 5 are alternate interior, but they're congruent, not supplementary. That's why it's not that one. And then lastly, looking at it again, 8 and 2 are alternate interior. Nope, they're alternate exterior. 7 and 3 are alternate interior. Nope, they're corresponding. 7 and 2 are same side interior. Nope, they're exterior. 3 and 5 are alternate interior angles and congruent. Okay, next one. Oh, this is a good one. This one, you have to kind of dissect the different parallel lines. So let me real quick duplicate. Okay, if 8 measures 119 degrees, how much do we have left? Hold on one second. Okay, if angle 8 equals 119, what is the sum of measures 1 and 4? Good thing we read that. So first, angle 18, or angle 8 is 119. Now, I told you to pay attention to X's and O's. That's kind of what we did. So everything that's obtuse, I'm going to make green. And everything that is acute, I'm going to make yellow. Now, it wants angles 1 and angle 4. Both of them are green. So I know all my greens have to be equal to 119. And because it wants the sum of those two measures, I know that 119 times 2 is 138. Okay. Next, which of the following are properties of parallelograms? Okay, so remember, we do know that there's certain special qualities about right angles and about rectangles and about squares, but here we're exclusively looking at parallelograms. Hold on one second. Okay. Opposite angles are congruent. That is true. Diagonals are perpendicular. That is false. That is only for rhombuses, squares, and technically kites. Adjacent angles are supplementary. That is true. Diagonals bisect each other. That is false. That is only for rectangles and squares. So 1 and 3 are, ooh. Oh no, I was wrong. Diagonals are congruent. Whoops. Diagonals bisect each other is true. If diagonals congruent are rectangles. So it's 1, 2, and 3. Choice B. Okay, let's take a look at the next one. The next one's got a lot of stuff to it. We're going to be selecting all of them that are true. This is one example of how you would have a question that had like a construction in it. So you're not doing the construction, but we're still considering the construction in the context of, there we go. We're still considering the construction in the context of the math problems. Okay, select all of the following answer choices that must be true. Okay, JA equals JB. Nope, not necessarily true. Because if you had your perpendicular bisector and you swung a small arc, these lines would not necessarily be congruent. They can sometimes be congruent, but they're not always congruent. JI, let's see. Whoops. So it's not A. Why am I moving? JI and JK, yep, that's literally the definition of bisector. AI and AK, yep, we talked about that bisector theorem, that's true. BI and BK, that is also true. IAJ is a right angle. Hopefully by looking at it, you know that's not true. IJA is a right, yep, we know that that's true. A is the midpoint of IK. Definitely not true. J is the midpoint of IK because that's where the bisector point is. So I went through that fast, but hopefully you know that one already. Next one. We have proofs. So you will have questions about proofs. Hopefully you're not going to be too stressed out about it, but let's take a look. Given that ABCD is a parallelogram, and honestly, I somehow lost the screen if someone's texted. I'm sorry if you texted and I missed it. Let's see. I have so many screens open. Okay, we're good. Given ABCD is a parallelogram, a student wrote the proof below. And which to show opposite angles are congruent, and we have to say why. Okay, well, this one's super easy because here it tells you that the triangles are congruent, and 90% of the time after you have triangles congruent, you have that CPCTC, which is number 7, or number 3. So I didn't even have to read anything. I just looked at the proof and saw, oh, in step 4, they proved congruent triangles. So that means that in step 5, it's most likely CPCTC, which in this case, it is the case. All right, let's go to the next one. It says QT and T are congruent. So we know these are congruent here. So this gives us an angle. QR and TR are congruent. That's going to give us a side. PRQ and SRT are congruent. That's going to give us our other angle. So we know that it's going to be angle, side angle. So we can eliminate B and C. And what comes after we prove angle, side angle? Almost always C, P, C, T, and then C. So really cut and dry. Okay, I have 3 more questions, and then that's everything that I have to show you. But if you have other questions, we can definitely do them. The diagram below shows P. Which one shows P at equidistances from points A, B, and C? Okay. This one is choice D. I'm 99% sure. Let me double check. And then this is, I think, where we talked about centroid before. This one I don't expect this one to be on your test. Is this it? Nope. 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 Okay. Oh man, hold on. Okay, there it is. These right angles, obviously, even just looking at the picture, you can tell that they're not necessarily equidistant. Oh no, that is true. Hold on. That one I'm going to have to get back to because I'm having a brain fart on. But let me open up Google Drive and look real quick. Because I did have the answers pulled just in case this happened, but obviously I lost them really quick. A, I thought so. It is choice A. Because these form right angles, that's why you know that the corresponding lengths are the same. So these right angles, and I don't think you'll see this on your test, but because we form those altitudes and we have like the bisectors, wherever they have the intersection, that's where we know that those pieces are the same. I was going to tell you D, but I was like, I don't think it's D. All right, last 2 questions. And I know we're going way faster than normal, but I've been teaching, and I've been teaching a lot today. Let's see. Find the value of the variable. The diagram is not to scale, which means don't use the protractor function. Again, this is corresponding or vertical angles 114 here. This means this has to be 114 degrees. We know that all triangles are 180 degrees. So all I would do is add this up. 61 and then subtract. And so my other angle that I'm missing is 19 degrees. The last one is, which is the correct 2-column proof? So all of them have the given. P and D are vertical angles. That is true. So PD vertical angle. So it's not going to be choice B. D and C are same side interior. That is true. So it's going to be, so we know it's not going to be choice C. C and K are vertical angles. That is true. P and K therefore have to be equal supplementary. That is true. So the answer is choice A. Okay, so this is where we are. I forgot to start the video for the first 10 questions, so when we're done, I'm going to probably have to redo that and put that up. Tomorrow, if you're one of my students, we're going to go back to A105 and continue to work. I am going to give you different questions. I'm going to give you more challenging questions, but I'm going to give you more. I'm going to make more challenging questions than this, but I'm going to make sure that the bulk of the questions you do are with the standards that you're going to have the most amount of questions with on the interim. Depending on when you're watching this video, Tuesday, if you're a freshman, you're going to be headed to a field trip. And then Wednesday and Thursday is your final exam or your midterm. Final exam. Wouldn't that be lovely? Okay, so that is it from me. I will put this also posted on to GwinnettMath.com. If you're one of my students, I'll end up printing it out for you so you have it. If you're not one of my students, then you're going to have to print it from GwinnettMath.com. Hopefully by 5:30, I'll also have all the videos that I've done, especially this one, posted. And that is all I have for you guys, unless there is something that you are dying for us to cover. And then otherwise, we're done. And I would normally play Kahoot, but we don't have a whole lot of people. So, okay. Well, I will see you guys later. Have a great rest of your day. I'll see you on Monday. Bye.